We are live with Edwin Brady, who is best known for his programming language design, and he co-authored perhaps the most famous esoteric second most famous, BF, second most famous esoteric language called Whitespace, and perhaps the most famous modern dependently typed language called Idris. Edwin, thank you so much for talking to us.
Thanks for having me.
Perhaps the most, you're perhaps the most known for your work on Idris. So can you please give us a brief elevator pitch for the language, for whom it is for, and why it's relevant these days?
Yeah, okay. So I'm always, we want to be clear that it's really a research project. So it's not something that I'd expect you to take and use in production. So I'll answer with that in mind. So the vision, I like to say the vision is to bring state-of-the-art software verification techniques into mainstream software development. So obviously I'm not going to claim we're there yet, but the decisions we make, the design choices we make are all about getting to a point where you've basically got no excuse just to prove the properties you care about of your program, because it's easier than not doing so. So that's the goal. That is all based on what I now like to call type-driven development, sort of by analogy with test-driven development. The idea being that using the type system, you can be very precise, or as precise as you want, about how your program is going to behave, and then arrive at a working program by a conversation with the machine. So maybe it's always good to have a 3-word soundbite, isn't it, or something like that. So I say programming is a conversation. That's 4-word soundbite.
Yeah, that's really cool, and I mean it also can propagate to other practitioners. I think even, for example,
right.
Yeah, even for example, work by Kostas and his team from Uppsala on success typing for Erlang.
Sure. Yes. Yeah. And I think actually that's an important thing to say early on is just to when designing a new language and putting it out there, you have to decide what it means to be successful. And success for an academic would not be having everybody using the language. In some sense, that would be a nightmare, because you've got to support the thing. And it's me and a couple of colleagues, we're not going to be able to support it on our own. Success, on the other hand, is getting the ideas out there and used by other people. So, for example, Haskell picking up full dependent types, or something like Rust. I occasionally get tagged in issues on Rust RFCs. On how do we bring more dependent types in. That to me is success, is people knowing the ideas and wanting to take them into more mainstream systems. And I wouldn't say that success typing has been necessarily influenced by dependent types, but it's certainly been influenced by the fact that a lot of people have thought that type checking is a good idea.
In my experience, for example, it's exactly what you're saying, is a conversation between me and dialyzer.
Right. Yeah. So dialyzer might say, "Hey, this doesn't quite work right yet," and your response will be something like, "Oh yeah, I better fix that," or it might be, "Yeah, but I'll save that for later." And it's very easy to think of tools like dialyzer or type checker in general as being there to tell you off when you've got it wrong, and that's absolutely not the way we should look at programming languages. It should be, programming languages are there as a tool to help us interface with the machine. In fact, it's, in some sense, it's a human-computer interaction problem, and it's probably be better if we thought of it that way a bit more. But I mean, it's still all too easy to think of when you get an error message as teachers telling you off, see me after class. And I guess with success typing, as the name implies, it's not so much about being told off. It's just about getting closer to something more precise. So I think that's what our tools should be doing, is helping you. Like in type-driven development, we put the type first, but that doesn't necessarily mean the type is the final type. As we write the program, we're going to learn more about the problem. We'll refine the type a bit more. We'll get a bit of feedback from the type checker, and maybe we decide that the type needs to be more precise. Maybe we decide it needs to be less precise, but all of that needs to be done with tool support. It's not something where we should just write the whole program and then feed it to the Oracle.
Right. Well, yeah. Well, before I think it's good that we present the ideas behind Idris. But now let's try to trace your footsteps along the path of compiler development, and go all the way perhaps to early years in a university or something. And I'm just really interested in how did you start developing compilers in the first place?
Right. Yeah. So it probably goes back further still, because sure, this will be a shock to everybody, but I have always been a massive geek, and I've been into computers basically since I was very young. So my parents bought a BBC Micro when I was about 5 years old, so I don't actually remember not mucking about with computers. And early on, I was learning BBC Basic, and interacting with the machine, and always thinking, I wonder if there's other ways of interacting with the computer. And I've always had this fascination with other possible programming languages. So I've always had that kind of strange interest in languages, in programming languages. So eventually, I went to university to do computer science, which in hindsight was the only thing I was ever going to do at university. And when it came to picking my honors project, there was one. The headline was "A Compiler to Teach Compiling," and the idea of it was just write a small language, but have visualization tools for like the parse tree and lexical analysis and the runtime system, so that you could trace how the source language ended up at a target language. And I loved doing that. I had enormous fun doing that. So that was probably the first compiler I wrote. It wasn't a tremendously useful language. So that I think the most complicated type it had was strings. But it was how I learned about parsers, runtimes, and compilers at all. So what happened next? Yeah, I got a proper job for a bit after that, working on a natural language processing system at a spin-off company from Durham University. And even there, I was working on domain-specific languages. So I was working on an inference system for so there's facts in a knowledge database, and questions being asked, and so they were being encoded, and we were inferring answers to questions, and all of that. It's in the end, it was a programming language problem. On the face of it, it didn't look like one, but it was a programming language problem, because it was make the runtime fast, have a parser that allows domain experts to state facts that they can add to the database. And after a couple of years of that, I decided it would be fun to go back to university and learn a bit about type theory. That's where I learned about epigram. So that was James McKinnon and Conor McBride. So they were James McKinnon was my supervisor. I did quite a bit of work with Conor McBride. They were designing a new language, epigram. And my thinking then was, this is all very cool, but what we can express here is very cool, but it would be nice if we could run these programs. How do we make this useful to a developer? And so my PhD ended up being, how do you compile dependent types? And it turned out there were some problems with just erasing types. Like just erasing types on its own doesn't really work, because you end up with a lot of stuff at runtime that's not actually a type, but it's still only compile time information. So it's like, how do we erase that? So everything I've done in all of my language implementation work, I think it's really been starting from that point of, these ideas are very cool. How do we run them? How do we eventually get them to end users, where the end user is a mainstream software developer or a practitioner? Yeah, that's about it, really. That's right.
And somewhere along the way, you did some work on esoteric languages.
I wouldn't.
That part.
I wouldn't go as far as calling that work. I mean, that literally was one evening after the pub. It was, a couple of us just went out for beer on a Saturday night, and because might have mentioned I've always been a massive geek. We were talking about programming languages, as you do, and thinking, oh well, you don't really need many characters to encode a programming language. And it's not just you don't need many characters to encode it on disk, for example, or encode it in memory. You can actually give some semantics to those characters, and let's see what happens if we just stick with the whitespace characters. And so I went home, and because I'd been doing quite a bit of work at that point on runtime systems, so I knew how to make a stack machine, for example. So I had one that I'd been working on for the target of epigram. So I kind of knew how they worked, and Haskell is a great language for making prototypes of this sort of thing. You can do it very quickly without having to worry about memory management, for example. And it just kind of worked. And we noticed that it was March the 30th. So we thought, this was before everyone got bored of April Fool's jokes, or maybe it wasn't. And we thought, okay, let's just post this on the internet on April the 1st and see what happens. And that is the thing that is still, I'm sure that has the most impact of anything I've ever done, probably ever will, and I'm okay with that. It's just a thing that if you happen to be working in programming languages and you think, hey, wouldn't this be funny? You have this kind of sense of humor. It's a quick thing to bash out. So we did.
Right. That's a cool story. Interesting behind.
Well, I mean, every so often it comes up for it out of the blue. So one day, and maybe the person who did this is watching. So in about 2008, I got in the post at work. I got a printout of, I don't know, it was just a load of blank sheets of paper. It was like scrap paper. And there was a letter attached saying, there's a problem with my whitespace code. I can't figure it out. I don't want to email it to you because I don't want it to be intercepted by anyone. I wonder if you could help. And my plan had always been to highlight around a bit of it, post it back and say, here's your problem. But I lost it. And I was never able to send it back. So if it was you who sent me your code, I'm sorry I wasn't able to help you. If anyone out there, I thought that was really funny, and I'm very sad that I don't know who it was or where the code went, because I mean, I guess if I ever find it, I can post it back and say, sorry, it took me 15 years to debug your code. It was just a bit tricky to type it all in. Anyway.
Right. Yeah. So, all right. Well, so basically, the whitespace thing and the Idris thing, as it turns out, are intimately related.
In a sense, yes.
Interesting. But yeah, well, what interests me a lot about this process of making basically research languages, especially Idris, is well, students around the world are said to read the Dragon book, and then they will be able to write compilers.
I'm not entirely sure that's true anymore, but
well, yeah, I mean, I myself found that it's already a little bit of sketchy of an advice. I mean, of course, people should still read the classics, yes.
Yeah.
But yeah, I would really like you to talk a little bit about what is actually kind of the difference and where do you go from reading the Dragon book.
Yeah, I mean, these days I wouldn't necessarily recommend starting with the Dragon book. It's I did say I haven't read the latest edition, so I don't I don't want to say things that are unfair. There's a lot of that in the edition I read, so the second edition that I was reading when I was doing my compiler to teach compiling project, and I learned a lot of good stuff from it. But it was based on how people wrote parsers and lexers at the time. These days, I think you certainly need to know the fundamentals of, you need to know how to write a parser. But the way you write a parser these days is probably with a parser combinator library. Like you kind of need to know how to refactor your grammar into such a way that that it's not hopelessly inefficient. But you don't really need to know all of the details that the Dragon Book goes into. Similarly, you don't really need to know a huge amount about code generation, unless that happens to be the thing you're interested in. I've never really written a code generator, for example. Not in the sense of spitting out assembly code. I've written a code generator in the sense of writing out C or Scheme or a target language. So definitely know the basics. Definitely have something like the Dragon Book to hand, so that if you're not sure how to do something, you can probably find it in there. But if you are interested in working on a new language, I think that probably the most important thing is to know about other languages. Like know how other people have tackled the problem of explaining things to a computer. Know the trade-offs. So that might involve, dabbling in functional languages, object-oriented languages, knowing a bit about linear type systems, so knowing a bit about Rust, knowing a bit about Prolog and Lisp, so just knowing the history of where things have come from. Like, you don't have to write big, sophisticated programs in all of these languages, but you do need to know what features exist. Because I think if you do want to design a new language, which, I mean, why not? It's fun. It's good to have something different about it. So don't just come up with a new syntax for an existing language because you think a different syntax would be nice. So try to take inspiration from lots of different languages that you've tried out and see if you can put them together in a new and exciting way. I mean, isn't that what programming language research is about to some extent, is putting old features together in new ways and seeing how well they work. So I would say don't get too hung up on understanding everything in the Dragon Book. Have it to hand, so that I say have it to hand. It's not actually here. It's in my office at the department. Have it to hand so you know how other people have solved long-standing problems. But better to know about how other languages work. Oh, and also it's, I think, well worth knowing a little bit of type theory, just a little bit of basics of lambda calculus and type theory. Again, because that's a way that people have solved problems for a long time. It's good to know how people have solved problems in the past. I think it's a lot easier to learn about type theory than it was 10 or 20 years ago now. There are more things that you can read. And of course, there are languages like Idris and Agda that you can use to learn those concepts. So learn a bit of theory. Make sure you know a few languages. Lock things up in the Dragon Book where you need to.
Right. These are great advices. And you mentioned code generation.
Yes.
What is a very popular advice for beginners or for people who already wrote some language, some toy language, but who maybe want to make their first real language, is to learn about LLVM these days.
Yeah.
And to use it as a target for their first real language. So can you please tell our viewers about your opinion about LLVM, what it is, and of course, if it existed in the shape that it exists now, because obviously, LLVM has a long history, right?
Yeah.
And it wasn't always this kind of universal target for everyone. Would you have used it as a target for Idris back when?
The question about LLVM comes up quite often. It's like, shouldn't we use LLVM as a target language? And I've tried it out a bit. I've had students try it out, which is much easier thing to do than trying it out myself. And I still don't think it's the right choice for something like Idris. It might be the right choice for a lot of things, but I don't think it's the right choice for me. And the reason I don't think it's the right choice is mostly because it doesn't stop you having to write a runtime system. So it saves you a lot of the difficulty of knowing your target architecture. I think that's a big thing. But you still have to think about how data is going to be represented, and you have to think about garbage collection, calling conventions, and maybe it comes down to what you're interested in. There was a time when I fancied myself as a runtime system author, and I thought it would be cool to work on it. And I think maybe if LLVM had been in the state it is now 10 years ago, then I would have spent some time learning more about it and getting it to work as an Idris backend. And I think if that's something that's, if when making a programming language, your interest is in getting the best performance out and having a lot of control over the code that's being generated, if that's your main interest, then definitely use LLVM. But my main interest with the latest version of Idris is not so much that as having a mature runtime system that already works really well, so that all I have to think about is the language design itself. The type system, getting the high-level language constructs and libraries set up in such a way that people can use them nicely. And for that, Scheme is absolutely, it was a surprisingly good choice. It was something I always intended to be just a quick hack, and then we'd move on. Maybe we would move on to LLVM, but it's become increasingly obvious to me that I'm not going to do any better than using Scheme as the target. So this is quite surprising because Scheme is it's a dynamically typed language. So your first thought would be, hang on, aren't there a lot of runtime checks that we've had a type checker work out that these runtime checks are unnecessary? Why do we have to do the runtime checks? And the answer to that is quite simple. You pick a version of Scheme where you can turn those off. So Shea Scheme, you can turn them off. And by the way, even if you don't turn them off, still generates code that's faster than what we were getting out of earlier versions of Idris. So that was the point where I thought, yeah, I'm not a runtime system author. Let's use one that's already really good. So it's got a really good garbage collector. It's got a good story about tail calls and continuations. That's all stuff that we can just use. So my advice to anyone who's interested in playing around with a toy language, especially if it has some kind of functional flavor, like if it's got closures, and especially if it's got a bit of garbage collection, is seriously consider using some flavors of Scheme as your target, because even when you're in the toy experimental stage, you will have a fast runtime. So and yeah, maybe you'd be able to do something better and faster with LLVM. Eventually, it's probably worth the effort. But you'll get the most performance for least effort if you pick a target like Scheme. So yeah, don't rule out things like Scheme just for minor little details like they're dynamically typed. Turns out it doesn't have the overhead that you might suspect, especially when you can turn it off.
Right, that's really cool. Very, very nice insight into basically picking your battles, right? While developing.
Well, that's the point, actually. Yeah, exactly. Pick your battles. Your battle very much might be, I'm fascinated by runtime systems. In which case, don't use someone else's, write your own. But that's not what I'm interested in. So
actually, what you're describing is somewhat similar to the insight of pure script people, because what they're doing is they're saying, okay, we're developing this language that we can't run actually, right? And then it's up to someone else to figure out how to basically write a run function, for our main monad or whatever.
Yeah.
Right. And it's beautiful because of course initially it was designed to compile to JavaScript.
Mm-hmm.
But these days we have so many backends for your script, and for me it's very fascinating that they managed to have an actual working Erlang backend as well.
Right.
And,
I didn't know about that.
Yeah.
I knew that they had a variety, but I didn't know they'd gone to Erlang as well.
Yeah, there's actually a company here in the UK that uses it in production, the Erlang backend, which is really cool. Yeah, they're doing video streaming and whatnot. Very nice. Yeah, and in a way, this all was enabled by the fact that it's agnostic to a big degree.
That was a deliberate choice with the latest Idris as well. So it was an accident to have multiple backends for the first Idris. It was just that someone thought, oh, I wonder if I could write a JavaScript backend, and it worked. And then for Idris 2, I thought, okay, that was obviously useful. So let's just have an API that people can use. Let's have kind of a smallish syntax tree that you can write your own target for. So there's an Idris to Erlang compiler now that I believe is good enough that it can compile itself, which is always that's kind of the definition of when your code generated for Idris is complete these days. Is it good enough to compile itself? So being agnostic about your target language is it's you have to make some compromises, but it's I think it's a nice thing to do these days. Like multi-platform, there's lots of platforms, and platforms aren't Linux, Mac, PC anymore. Platforms are, it's for the web, it's for .NET, it's for JVM, it's for PHP or whatever. So I think that's a good thing to be able to do, especially like Erlang. If you're doing distributed systems, then Erlang is a fantastic choice. So if you want to do distributed systems with pure functional programming and fancy type systems, then let's take the best of both worlds if we can.
Yeah, for sure. And which system isn't distributed anymore? Am I right?
That's a fair point. Yeah.
So let's kind of get back to from compilers in general to Idris and talk a little bit more in details about it, but still while being somewhat beginner/intermediate friendly. I know for myself, when I have to explain to someone what is Idris, I kind of wave my hands around and I say, well, Haskell, Agda and Coq, and it's like kind of somewhere in between. Right? So how would you say what if you would have to compare Idris to like practical typed languages like Haskell and to proof assistance, like where would you put it?
So, I mean, firstly, I love that we're in a world where you can say practical typed languages like Haskell. That's fantastic that we've got to that point. So thinking back to just the beginning of working on Idris, I'm thinking there's a question of, would I still start a project like Idris now when Haskell exists? And I think the answer is probably yes. Because Haskell it's got to this point where you add more and more language extensions. So you've got Haskell 98 that essentially nobody uses. It's not completely true. There are people who stick to Haskell 98, but most people will stick to a small collection, or maybe a large collection of favored extensions. But it's the point is there are extensions. You never quite know which Haskell you're at. You never quite know what's coming next. And there's all this wonderful new power that's coming into Haskell, and you see people do fantastic things with it. But at some point, I would want to consolidate all of that. How do you take all of these wonderful features and make them simple? Now, I don't like to use the word simple, but I'm going to use the word simple here in the sense of small. Make the language as small and orthogonal as possible. So that's what I think Idris is, partly by accident, but partly because all of the things that you might want to express using hundreds of Haskell extensions, you could do instead by writing a type level program that is just the same language as your ordinary term level language. So I think I'm going to assert that Idris is significantly simpler than Haskell, because the type system allows you to write programs in it. I don't say type level programs, I just say programs, because they're the same thing, aren't they? So yeah, if one were to start again on a language like Haskell, knowing what we know now, I would sort of imagine that it would be, I would hope it would be something like Idris but lazy. Maybe that's where we'd want Haskell to be. So the another just sort of minor differences are things like prioritizing interactive editing. So Haskell's picked up a bit of that lately with sort of interactive tooling, and particularly with typed totals. But one of the things that makes type systems hard, especially expressive type systems like Haskell's and like full dependent types, is that getting the whole program right is challenging, and you get error messages that say your program doesn't make sense, but it's up to you to figure out why, because I can't give you the full details. So interactive editing is essential, really, once you have more sophisticated programs to work with and to work on. And I think really thinking about not only what complete programs look like, but what partially written programs look like is crucial. So that's another thing that I think Idris takes a lot more seriously than GAC Haskell does. But GAC Haskell and various tooling support is taking that more seriously now. So that's how I compare it with Haskell. On the other side, comparing with Agda and Coq. So again, thinking back to when I was starting to work on Idris, Agda was around, but Agda 2 was in its infancy. There had been an earlier version of Agda that differences in its type system. So, and I had all the components, so I thought, I might as well not be tied to other people's design choices. I might as well just have a go at my own. And at that point, I was coming at it more from the direction of what kind of programs will we run? What kind of programs will mainstream software developers want to run? So I kind of started from the back end and worked towards the front end. That's what I'd done for my PhD work anyway. So I'd like type erasure so that you could compile dependently typed programs at least moderately efficiently. Whereas Agda, I think, was more starting from the other direction of what kind of things can we express in the type system? What kind of interesting things can we prove? I think we've got to a point now where we've kind of met in the middle. So, and now I think it's great that both Agda and Idris exist, because every time one gets a feature, the other one has to catch up. So that sort of competition, I think, is really healthy. So I go along to Agda meetings, they come along to Idris meetings. We learn what we each learn what the other one's done. So like the last Agda meeting, I shared some tricks for how I'd made Idris 2 a lot faster than Idris 1. Because I want Agda to be as fast as Idris 2, so that I have to kind of rush ahead again. But I think the contrast is really about where the initial focus of the language was, and I think Agda has always been more about proving interesting things, and Idris has always been more about how can we make it easier for mainstream software development to be able to prove more things. Like if I can explain something to another programmer about why my program works, I should also be able to explain it to the compiler so that the compiler can keep me right on it. And that's kind of what we aim to do. The contrast with Coq is, I think, it's quite a bit bigger. So the Coq really is primarily a theorem prover. You can extract programs from it. People do. It's people do in a fairly big, significant way. But I don't really think of it as a dependently typed programming language. It is based on dependent type theory underneath. That's the way you do your proofs. But what people will typically do is write down a specification and then derive a working program from that specification, rather than add some indices to types and then write programs over those more expressive types. So it's really it's taking a very different, it's encouraging a very different approach to writing programs than Idris and Agda do. So yeah, all of these systems sit in a sort of different point in the design space, I suppose. Haskell is sitting in a point where we've had pure functional programming for a long time. Let's make the type system a bit better. Idris is maybe, what would we do if we were to start again? And let's say we like the Haskell syntax, but we want to make the type system, we want to consolidate all of the fancy type system features. Agda is similar, but with a focus on proving. And then Coq is really, I don't want to say just a theorem prover, because it is a lot more than a theorem prover. People write very big, sophisticated software packages in it, but it's definitely more of a focus on theorem proving. Maybe there's a spectrum: Haskell, Idris, Agda, Coq. There's a spectrum of where you are on the programming side, where you are on the proving side. That's oversimplifying, but I guess what is a YouTube stream for if not oversimplifying?
True. Our whole channel.
Yeah.
Well, actually, it's not fair to some of our speakers who are talking about in details about what they're working on the GHC right now. Which, yeah. Anyway, yeah. Actually, you talking about Coq. For me, it's I see some parallels to LaTeX, right?
Mm-hmm.
It's it's a programming language, which is primarily a markup language, but it is a programming language.
Yeah, sure.
So here's a kind of similar thing, right? It's a theorem prover that's also a programming.
It just happens to be a programming language as well. Yeah.
All right. So you've mentioned already, and you were very upfront about it in your elevator pitch, that Idris is a research language. But when we talk about research languages, we really talk about two things at the same time, in my opinion, at least, right? One is a research language being a vessel for research, right? When the language itself is the object of the research. And another thing is when a research language is a platform for research. Would it be fair to say that Idris is both at the same time? That Idris itself is the object of research, but it also enables PLT research or dependently typed research?
We certainly do both. I mean, part of the reason for Idris existing in the first place was I just wanted to have a dependently typed language that I could write programs in. And then I thought, okay, once that's finished, then I'll just move on and write the programs. But of course, it's not going to work out like that, is it? Because you suddenly think of other things you might want your language to do. So there's definitely those two sides of how do you make the language better, and then what kind of interesting things can you do in the language? And I think we do both. There's, I think at the minute, I suppose to focus on would be metaprogramming. So how do we make the language nicely extensible? How do we add the reflection features that make theorem proving easier? Because, like it or not, it's not really a theorem prover primarily. But if you add sophisticated types, you're probably going to have proof obligations arise naturally that you just need to deal with. So how do we make it easier to do that? That's certainly a language design question. Then there was the question of dealing with protocols and states, and the fact that it's a pure language, but the reality is the world, the outside world has things that exist in certain states. How do we represent that sort of thing? So linearity, linear types come in, and so how do we bring that into the language and make them usable? So all these questions just arise naturally once you start writing programs, which is fine. That's one kind of research that we're going to do with Idris. So actually, those two kinds of research, how do you develop the language and what can you do with the language? They really feed off each other. Because as soon as you try to do something, you find you might need another feature, and then you have to ask, well, should I add the feature? Can I do this in a library? What's the best way to approach this? So I think people do both.
Right, and it's certainly a fascinating feedback loop. You have mentioned linearity. As far as I understand, this is one of the standing out features of Idris 2 compared to Idris 1.
Yeah, it's the linearity part is still experimental, but and people are using it in practice, but this is all part of quantities. So quantitative type theory is the core language that Idris is based on. So fancy sounding name, but all it really means is every variable has a quantity attached to it. QTT itself is kind of agnostic in what the quantities can be, but just for the sake of simplicity, not adding too much in one go. In Idris 2, they can either be 0, 1, or unrestricted. So 0 means never used at runtime, 1 means used exactly once at runtime, and then unrestricted is the world we used to be in, where everything had no restrictions. So linearity is interesting, and we can play with, there's all sorts of fun we can have with it. But by far the most useful is this 0 quantity, because thinking back to where I came in working with dependent types, it was all about there's a lot of stuff in the type that's going to leak into runtime if we're not careful. Tried all sorts of techniques for getting rid of that. So I came up with the idea of noticing which arguments could be uniquely determined by which other arguments, and then just erasing them. And then I had a student who had a whole program inference mechanism that that could tell you what was never going to be used and erase it. But quantities make the whole thing much simpler, because the type checker will tell you if something is needed at runtime or not. If you say something is compile time only, the type checker tells you if you violate that. And that has proved to be, I think, extremely useful, because if you're not very careful, you can have things leaking into your program that you really didn't intend, and it's like, not only does the program become slower, the complexity becomes worse. So QTT really stops that being a problem with the zero quantity. And once you've got zero and unrestricted, you might as well see what you can do with other quantities. So it's fun to see what we can encode with linearity. It's kind of ugly to encode anything at all interesting at the moment, but I guess that's one of the language design things we're going to be working on, is how do you make that less ugly? And it's probably going to involve some work on the type system, like the core type system, to make it nicer to work with. But I think that's certainly going to be a line of research over the next little while. For most users, like you won't really notice that Idris 2 is based on QTT and Idris 1 isn't, except in places where you have written programs with things accidentally leaking into the runtime. In which case, Idris 2 has probably just been very helpful to you. It's just told you that a compile time thing is actually runtime, and you might want to think about whether that was necessary or not. I've forgotten what your question was. I just started rambling. I do that. Sorry.
Right. No, I mean, I was asking about how essential is QTT for Idris 2.
Oh, right. Okay.
What are some other differences between 1 and 2, and how in general you pick version numbers? Because I mentioned PureScript already.
Yeah.
Right. They're very the original language creator already said, okay, it's good enough, I'm leaving. You guys figure it out, and girls, and they're still major version 0, even though it's very usable, right? So how do you pick your version numbers, and what's the big some other big difference between one and two?
Yeah, I don't really know the answer to that. I'll say why I call it Idris 2 rather than just changing the version number. It's a completely new implementation, so it's not a completely new language. But it's a completely new implementation. So we're currently confusing some people by calling it Idris 2 version 0.5.1. That was because I needed you need a between 1 and 2, but that also says this isn't the final thing yet. So eventually we'll get to Idris 2.0, and that will be the version number. I would say that you shouldn't use Idris 1 anymore. Idris 2, even though we're calling it Idris 2 version 0.5.1, it's still significantly more robust than Idris 1. Like it's at least an order of magnitude faster. It's certainly more robust because it's implemented in Idris, so we've been able to take advantage of the things that we've been advocating to, so that the fundamental problems we had in the Idris 1 implementation just can't happen because the type system makes them not happen. Now, obviously, we still have issues that we need to deal with. It's not there's no way of saying, oh, I'm using fancy types, therefore my program has no bugs. The world doesn't work like that, unfortunately. But the bugs we do have generally kind of superficial. It's not we don't really get difficult bugs in the core type system implementation because I put quite a bit of time into setting things up so that couldn't happen. So yeah, Idris 2 is a lot more robust. The fact that it's implemented in Idris itself means that we have a huge incentive to make it go quickly enough and be responsive enough. What are the other differences? So QTT is going to be the main difference. We did we've got some different decisions about what goes in libraries. So in Idris 1, we basically threw everything into the prelude so that kind of standard thing that's loaded when you start up Idris, and it was full of all sorts of stuff that I've no idea how it got in there. Like there was a factorial function in the prelude. Why would you have a factorial function in the prelude? I don't know. I think there might even have been a Fibonacci function in the prelude. I had no idea how that got there. So Idris 2 has had quite a bit more thought put into that sort of question. So the prelude is in a sense a part of the language in that it's just the things that the rule of thumb is. I believe that a non-trivial program, all non-trivial programs will need it. Then it goes in the prelude. Now that's not very formal, but it gives some kind of way of deciding. So if you're moving from Idris 1 to Idris 2, you might have to import more libraries. So you might run into problems with quantities, which are usually easily fixable. You might have to import some libraries, but otherwise it's basically the same language.
Cool. Yeah, I mean, with stuff that goes into Prelude, there's this phrase, you know it when you see it.
Yeah, and I can't give anyone a useful definition.
Yeah.
And if someone adds something, and if someone, people very rarely add something to the Prelude because I think it's very hard. The burden of proof is on the person who wants to add it, I suppose now. But if there's something that's borderline, I'd probably err on the side of, yeah, okay, let's take it. I guess it depends. But yeah, so we've been a bit more careful with that. I mean, apart from anything else, having a load of stuff in the Prelude means you have to load a load of stuff into memory. And we already have to think quite carefully about how much memory we're using because of the nature of a dependently typed language is you have to be able to evaluate programs at compile time. So you have to be able to access them somehow. So there are tricks we can do to not have to have them in memory all the time. But if the Prelude's bigger, we have to work a bit harder. That makes things slower. It's not a great reason for having a smaller Prelude, but it's one of the reasons for having a smaller Prelude.
Yeah. Okay. Let's talk about the dreadful thing of adoption of a language. You mentioned that you aren't too happy when people pick up your work.
No, I wouldn't put it that way. I'm always very happy that people are using Idris. I think it would be we'd have challenges that we currently we wouldn't know how to address. If millions of people are using Idris, then we can't support that. I mean, on the other hand, if millions of people are using Idris, I suppose some of them are going to be feeding back into supporting it. So that is the nice thing about building a community is that the community will help. So like at the minute, I'm spending most of my time dealing with teaching related things. So I have essentially no time to work on Idris, but having built a bit of a community, it's not such a big deal because there's a few committers. So I suppose if we did grow, I'd be able to take more of a step back. So it's not a completely bad thing.
Right.
And I don't want to discourage people from taking up Idris just because I don't have the time, because other people will be able to help. But I think it's just not a primary thing. If this is probably a general rule, if you create a programming language with the intention of people using it, it's not going to happen. Now, if you happen to be a big company where you can say to your employees, you're going to use this language, that's a bit different. But no individual is ever going to be able to do that. Right. So our goal just has to be to get the ideas out there and to allow people to have fun playing with it. And then maybe the odd one, I know a few people are using Idris commercially because they've had some fun with it as a hobby thing. And like commercial uses tend to be sort of little tools on the side that nobody's out there betting their business on Idris, to my knowledge. I hope they're not anyway. But there are people using it for tools to support their other work, or to. I think I've seen things like using Idris to write a kind of baseline proved correct version, and then writing another version alongside, and you can do fuzzing to see if they behave the same way, that kind of thing. So people are using Idris in that kind of lightweight way, which is nice to see.
All right. So yeah, well, on GitHub, for example, we see that there's some activity and some pretty popular repositories as far as Idris is concerned. And the most popular one is something that basically mimics Conduit library in Idris. Mm-hmm. So it's for stream processing, and my question to you is like, have you used this particular library, and have you looked at what people do with Idris and try to kind of play with it?
Yeah, I keep an eye on what libraries people are writing. So we have a wiki page that lists a library. I don't think that streaming library is on our library wiki page. Come to think of it, not sure. So I haven't used it. It's not generally the kind of program I write, but I know a lot of people do. So be interesting to see what people are doing with that library as well, I suppose. Yeah, so there is a growing library ecosystem. There's one of the challenges always is where are the libraries? What libraries do I use? It's one thing that could easily put people off using a language if there's not enough libraries and you don't know where to find them. So it's nice that they are being developed. So the things you'd expect, like parsing libraries for JSON, XML. I had an intern over the summer do a graphics library. That's quite nice to see. So you've seen the gloss library in Haskell. So it's a thing that allows you to describe pictures and then write pure functions to manipulate pictures. So I thought it'd be quite a fun thing for teaching. So we've got so a bit of basic support for graphics and end cursors and user interfaces. We've got a JavaScript backend, so people have written libraries there to help to work with that. Oh, there's an Idris port of DAL, so the configuration language. So there's a few things slowly appearing. What we don't yet have is a definitive package repository and package manager. People are working on it, so I think a lot of people swear by Nix for that sort of thing. I'm not familiar with Nix myself, but so yeah, there's plenty of activity, which is lovely to see. Mostly hobbyists, but that's fine.
Yeah, and regarding Nix, of course, it's. I like to say that it's a correct choice. It's not necessarily correct from the standpoint of budgeting for companies, or at least not for every company. But it's correct in a sense that, you know how Phil Wadler tends to say that there are things that are discovered and that there are things that are invented, and Nix is basically discovered because it's in my opinion a correct formalization of what does it mean of the meaning of a piece of software. Like it basically formalizes what is a unit of software, and then from there it kind of builds the system to put these units together into meaningful artifacts. Yeah. And this is if for I think that for Idris there is nothing better than using Nix as the.
I mean that could make some sense, but we still need some place where people go to some web page that says if you want library X, you type this command and behold, there is the library. Right. So whatever thing we're using under the hood, we need that on the surface, which we don't currently have.
Right.
I'm sure it'll appear eventually. It's I mean it's not really something I can devote my own time to, but if someone does it, I can certainly put it on the web page and say this is what you use thanks to these wonderful helpers.
What about kind of blessing certain libraries in the same way? Because in my experience, one of the problems with Haskell, for example, is that not that its ecosystem doesn't have the libraries, it's just because there are 5 libraries that do the same thing with completely different opinions about how it should be done. And then you kind of get your attention as an adopter gets scattered between these different, basically, preferences of authors of the libraries. So what's your opinion about like blessing libraries as a language?
Yeah, I mean that would be because that's the Python approach, isn't it? You come batteries included. You have a load of libraries that are part of the distribution. And I would prefer to go that way, but we're not really at a point yet where we've got competing libraries that where the competing libraries have to exist first before you decide on that. Now, I think we would say, what I would probably say is hopefully everybody would be actively involved in the Idris community and talking to each other, and hopefully we'd get everyone to eventually collaborate on the so I kind of hope it would naturally lead to one version winning out, but we haven't reached a point yet where that's been a problem we have. I'm hoping we will reach a point where we have that problem, in which case, yeah, I would prefer to have one blessed version. Choice is terrible sometimes, isn't it?
Oh yeah, for sure.
Um,
and you have the luxury of not having a committee, right? Because it can be paralyzing at times. Yeah, because for example, even with small things like default instance for JSON encoding for a byte string. Yeah.
Yeah.
So it's theoretically impossible to pick one. Yeah. So
yeah.
Since it's opinionated, it's not there, and then it's a huge. In my experience, even this like tiny thing is a huge thing that I have to explain to people who are working on my code and want to like encode a byte string as JSON.
Yeah, that's the decision I made. There were other decisions I could have made, but I didn't. That's just the way it goes, unfortunately. Yeah.
Right. So let's round up the interview part and move to questions. So, what are your plans for the future of Idris? And do you want, aside from metaprogramming, do you work on some new and exciting research?
Well, I would probably start with metaprogramming because maybe that is the new and exciting research. So the primary goal for Idris right now, because I don't have an awful lot of time to work on it at the moment, is performance. So I think it's absolutely crucial for a system like this to be responsive. Now, we can't always be responsive because the nature of a dependently typed language is that there are type level programs, and if you write a slow type level program, I can't help you. I can't magically make your program fast. But on the assumption that your type level program is fast enough, we need to be able to respond as quickly as possible. So yeah, primary focus is performance. So one way I'm thinking about that at the moment is just taking advantage of the fact that Idris has implemented its scheme. We could use the scheme evaluator to do compile time evaluation of expressions, and that has, in my current experiments, it's made the evaluator about 20 times faster, something like that. It's between 10 and 20, depending on what I feed it. So that's crucial for metaprogramming. Metaprogramming has to. We're running programs at compile time, so they better be quick. Now, one project that some colleagues are working on and I'm helping out a bit with is called Frex. So Frex is it's a library for I guess the headline would be automatically proving equivalences. So take an algebraic theory, take an expression in that theory, say monoids, groups, whatever. So express that as, or take the Idris type that expresses an equation, translate it into a form that Frex understands, do the proof, and then that proof is something that you can use in your program. So metaprogramming is essential to making that work effectively and usably. And an awful lot of my effort over the last couple of years has been making Idris fast enough to compile the Frex library in a reasonable time to make it responsive. So our definition of responsive here is basically Jacob Nielsen's of it's under 1 second ideally. If it's over 10 seconds, then it's a bug. So we're generally doing well on the under 1 second there, I think. So yeah, my primary thing is about performance. But yeah, what can we do with metaprogramming? Other things would be type providers. So this is where you run a program to calculate what a type is going to be. So how do you know that you're interacting with a database correctly? A database has a schema. Maybe the compiler could run a program to query the database schema so that you know that the rest of your program is interacting properly with that database. Or another thing we might use that for is I have a student working on verifying properties of state machines. So you could take a graphical description of a state machine in dot format, so you draw it in GraphViz. You can then parse that dot format, generate an Idris type that captures the meaning of the state machine, and then try to do proofs about whether it's always possible to get into a state. So kind of mini version of a model checker in the type system. Again, that needs good metaprogramming for that to work effectively, because we'd really like to just to be able to draw the state machine, and that's your program, and through type providers and metaprogramming. That you look at the picture and that is your API. So It all comes down to metaprogramming. Everything interesting I have in mind seems to come down to good metaprogramming. That's definitely
really,
#1 priority.
That's really interesting. It's the story about the picture being the API is somewhat one of my favorite examples of why metaprogramming is very practical is how it's handled in Elixir. Basically, they have essentially Lisp there with quotes and quotes and whatnot. And what they do to generate Unicode, their Unicode module, is they take Unicode standard, and then they have like code generator basically that takes standard and builds the actual program in Elixir that handles Unicode. But the thing that you mentioned about getting database schemas, so do I understand correctly that you plan to have like kind of a side effect during the compilation
of
actually doing it and actually checking against it?
Yeah,
That's
of course,
amazing.
the danger there is it would be unchecked. It would be completely possible to write a program that deletes its own source code because it's a side effect. So we could say, well, don't do that then. I mean, that's step one is just to say don't do that then. But who knows? You go to your package manager, you download a package that promises to be this really helpful library, and then it just deletes your hard disk. I mean, that's always a risk when you download a program off the internet. But I wonder if there's some nice type-based way to prevent that sort of thing, and I think there probably is. So I'd like to think about that. Like, can you encode capabilities in the type? So rather than the type being IO, the type would be some safe fragment of IO, or like a read-only thing. I think that's possible. We'll need to think about it. I mean, David Christensen several years ago did type providers in Idris 1 and basically figured out the idea. But I always had this nagging worry that somebody could write a program that deletes someone else's program. So I'm sure nobody's going to do that. But it's going to be hard to do by accident. But you kind of also want to prevent people doing it deliberately. It reminds me of my favorite ever GHC bug. It was about 2003 or so. There was a bug in a development version of GHC where if there was a type error, it would delete the source file, which I guess fixes the problem. That one crops up on the internet occasionally of an example of where things can go wrong.
It's in gaming there's this concept called permadeath. Yeah, when the character dies, it's over. So it was a version of permadeath for GHC. Yeah, that was quite epic. So we have just one question, as far as I understand. Denise might correct me if I'm wrong. So the question is the following. So does the fact that Idris doesn't do ASM generation really means it isn't needed? It seems like there are many really successful I guess the author means that there aren't many really successful languages that don't do ASM gen, or at least LLVM. This is like kind of the first part of the question. And the second part of the question, I'll ask you after you answer this.
I'm not sure I understood what the question was. Like there are the mainstream successful languages out there. They would typically, as far as I'm aware, you've got .NET, JVM, or LLVM as targets. That seems to be pretty much where we're at. I don't think the reason for their success is really much to do with the platform they're running on. But I do think if you've got the engineering time to write a good runtime. I mean, I'm using Scheme because it's great for what I want, but it's also not great in some ways. Like there's things I want to be able to tell it but can't. So like maybe I want to be able to unbox integers, for example. So the primitive types it has are really kind of awkward. So in the long run, if I had a big enough team of engineers, I would certainly want them to write an LLVM-based runtime that took advantage of everything we knew about the source language. I just don't have that luxury. And I guess the languages that have become mainstream in a big way have just had the time to be able to do that.
There is correlation, but perhaps there is no causality, right? Like perhaps it's the other way around.
I mean, obviously I'm completely guessing here, so I don't know. But that would be my guess.
Also, there are some counterexamples, right? Like Elixir that I mentioned several times, which is extremely successful, and it doesn't concern itself at all about with low-level stuff.
And well, the point there is the Erlang runtime, isn't it? So
yeah, it's it used to be exclusively targeting Erlang. Now they have a very interesting. Now they have kind of a version with hybrid runtime when they execute parts on GPU, which is
also,
amazing. Yeah.
Compiled to JavaScript languages these days are,
Yep.
I think, that, like it or not, that is a big platform for. I mean, look at Electron. It's not even on the web, but that's compiled to JavaScript. So, I mean, TypeScript is very popular. So it's hard to say whether TypeScript is a compiled to JavaScript language or merely a type checker on top of JavaScript. But it's another platform that successful languages are using.
Okay, and so the continuation of this question, or maybe another question, is that are there not features of the GHC runtime system that would be difficult to have in Chess? I guess you mentioned it, and the person who asks this question mentions software transactional memory.
Well, how would we compile software transactional memory? I'm not really sure what that question's asking.
Yeah. Yeah, me neither. I mean, as far as, again, I don't know the exact implementation of STM and Haskell, but as far as I understand, it uses basically the primitives that we're having, like tvar, mvar, etc. And
so, okay, I'll give a related thing actually that we have encountered. So one, so remember earlier I said that if you want to be agnostic on your back end, you have to make a few compromises. So one thing that we do for foreign functions is if you've got a foreign function, you give basically a list of descriptors that say how you compile that function on a particular back end. And if the back end doesn't understand any of the descriptors, basically it's a compile error, so you can't do that. And the most difficult thing we've encountered so far with this has been concurrency. So not STM specifically, but every language has its own concurrency primitives. Even like so the backends that ship with Idris 2 at the moment are Shea Scheme, Racket, so another flavor of Scheme. Well, it's a bit more than the flavor of Scheme, and JavaScript. And even between Shea Scheme and Racket, there's enough differences that we have to think quite carefully about what the primitives even are. And they behave in different ways, because Shea Scheme uses pthread underneath, whereas Racket has its own runtime green thread implementation. So they don't necessarily behave the same way. So all we can really do is have this compromise of saying, yeah, when you write your concurrent code, you have to know what your target is and just accept that it won't be portable, which is disappointing. But I think, from what I know of STM, I suspect we could implement it on a Scheme backend if we had the right primitives. We could implement the right primitives in Scheme. But I don't know if we would be able to do that on a JavaScript backend. And I think we just have to accept that that's the way it is.
Okay, as far as I understand, that's it in terms of questions. Thank you very much, Edwin. It's been truly an honor to.
Thanks for having me. It's always nice to come and ramble on the internet about things I'm interested in. So happy to do that.
Yeah, I hope that we'll speak again, maybe about some more narrow subject. And
sure.
Yeah, thank you very much.
Thank you.